Next, we will discuss about the concept of isotope, isotone, and isobar. So these three are actually very confusing terms, but very simple to remember if you know what is the basic difference between these three terms. So isotopes are actually same elements that contain equal numbers of protons but different numbers of neutrons. So in isotope, your proton number is same, but the neutron number is different. So in nucleus, for example, if you take hydrogen, here we have one proton and no neutron. Here we have one proton, one neutron. So this is called protium, this is called deuterium, this is called tritium. Here you have one proton and two neutron. So these three elements are called isotopes to each other. Here proton number of proton is same, but number of neutron is different. So these three are called isotopes. Now in case of isotone, so elements that have same number of neutrons and differ in the number of protons. So in case of isotope, we have same number of proton, different number of neutron. Here it is exactly opposite. So you have different number of uh, proton, but the same number of neutrons. So these are called isotone. For example, if you take O16, N15, and C14, so in case of that, we have different number of protons, but we have same number of neutrons. So these are called isotone. Again, if you see silicon and phosphorus, we have different number of protons. Here we have 14 and here we have 15, but we have same number of neutrons, that is 16 in both the cases. So these are called isotone. Whereas in case of isobar, we have different elements. That means the number of proton is different, but we have same atomic weight. Now, atomic weight is a summation of number of protons and number of neutrons. So we have different number of protons, but we have same atomic weights. So that means we have both the proton and neutrons different, but the atomic weight is same. For example, if you take this argon and calcium, so here we have 18 protons and 22 neutrons. Whereas in case of calcium, we have 20 protons and 20 neutrons. See, both the protons, number of protons and number of neutrons, both are different. But this atomic weight, which is 40, that is identical. So we have only same atomic weight. So that's why these are called isobar. Here we have some more examples. You can take this one, cerium or selenium, cerium 76, selenium 76, or you can have this iron 58 and nickel 58. You can have argon 40, potassium 40, or calcium 40. And if you get sodium 24, magnesium 24, cobalt 64, nickel 64, these are all the pairs that are isobar to each other. So just a quick recap. In case of isotope, we have same number of protons but different number of neutrons. In case of isotone, that is exactly opposite. We have same number of neutrons but different number of protons. And in case of isobar, both the number of protons and neutrons are different, but we have same atomic weight. Now let's see some examples of isotopes. So we have already discussed about the isotopes of hydrogen in the previous slide. Let's see it again. So we have these three isotopes of hydrogen. In protium, we have only proton, there is no neutron. In deuterium, we have one proton, one neutron. And in case of tritium, we have one proton and two neutron. Now in case of carbon, we have carbon 12, carbon 13, and carbon 14. So if you see carbon 12, we have 6 protons and 6 neutrons. In case of carbon 13, we have 6 protons and 7 neutrons. And in case of carbon 14, we have 6 protons and 8 neutrons. Now let's see the isotopes of oxygen. So we have oxygen 16, oxygen 17, and oxygen 18. So in case of oxygen 16, we have 8 protons and 8 neutrons. Whereas in case of oxygen 17, we have 8 protons and 9 neutrons. And in case of oxygen 18, we have 8 protons and 10 neutrons. So these pairs are called isotopes to each other. Now let's see the IUPAC periodic table of the isotopes. So I will recommend you that you go in that website and you check this periodic table of the isotopes. So in this periodic table, it is given that one element, how many isotopes are there for each and every element. You can see these wheels. So the number of segment of these wheels tells how many isotopes are there. And you can see the color coding as well. Here the color coding is not properly visible. You can go and watch from the website that what is the meaning of these colors, different colors, pink, yellow, blue, white. So I will strongly recommend you that you go and just take a look of this IUPAC periodic table of isotopes.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.